Hello everyone, myself Dr. Kaibalya Prasad Panda. I am working as assistant professor in the Department of Electrical Engineering at Pandit Deendayal University, Gandhinagar. So it's a pleasure to be here in front of you because the students, two of the students, Rishika and Shree, who are our B.Tech final year students, they have developed a project, major project on multi-level inverter. And this multi-level inverter having different features like common grounding ability, single DC source. With single DC source it can boost the voltage, and there are many other features which will be explained by the students now.
Hi everyone, I am Rishika Sharma. I am here with my teammate Shree Solanki. We are students of Electrical Department at Pandit Deendayal Energy University. We have carried out our major project on building transformer-less multi-level inverter, which has some novel features. Now, I will introduce you to the experimental setup of our multi-level inverter. We have used a microcontroller to provide control signals to our gate driver circuits that we have designed. These gate driver circuits amplify the signals coming from the microcontroller and provide it to the switches so that the switch can turn on or turn off. Then these 9 switches are incorporated into our power circuit. Our power circuit consists of 3 switched capacitors and 3 diodes. We have used a regulated DC supply to provide input to our multi-level inverter, and as you can see, we are getting a 9-level stepped output.
Hello everyone. As Rishika explained, we have worked on a novel 9-level 9-switch inverter. Before we jumped on to the experimental results, we first verified simulation results. Over here are the simulation results for unity power factor analysis, lagging power factor analysis, and sudden variation of the grid current. Moving on, we also simulated many conditions such as sudden voltage variation along with modulation index variation. After having thoroughly validated simulation results, we moved on to create an experimental setup. As you can see over here, we are providing an input voltage of 50 volts and we are getting a 2 times boosted output over here of 100 volts. Moving on, here are the other test conditions, dynamic test conditions under which we have gotten our experimental results. Firstly, we can see over here the fundamental frequency control. Under fundamental frequency control, we have the voltage and current waveform for the load conditions of resistive load, steady state voltage waveforms of all 3 capacitors. Then we have also taken the voltage ripple waveform for all the 3 switched capacitors, and it has been taken under AC coupling. Next, we have taken the under fundamental frequency control more under load variation conditions the following waveforms. Next, we have taken under change of frequency conditions from 50 Hz to 100 Hz the following voltage waveforms for the 3 capacitors. We can see that the current ripple has reduced over here. Next, we have taken these are the compiled results for modulation index variation. Here we have also compiled the results for the capacitors, and we can see that they are self-balanced even under dynamic conditions. Next, we have the experimental results under high frequency control. Over here we can once again see that under high frequency control the voltage and current waveform has been compiled for your viewing. We have then taken the various results under the change of modulation index from 0.3 to 0.5 to 0.9, and we can observe over here that the voltage levels have changed from 3 level to 5 level to 9 level. Similarly, we have also conducted a change of modulation index settings for 0.7 to 0.9, where our voltage waveform goes from 7 to 9 level. Over here, we have also compiled the capacitor voltage waveforms. Finally, we would like to conclude that we have created an experimental prototype over here, which has been made for a novel 9-level switched capacitor common ground featured multi-level inverter. It has self-balancing capacitors, and we also did the simulation under closed loop control, and we have done rigorous testing for experimental setup under various dynamic load conditions. In future, we plan on integrating our experimental prototype within a PV grid system. Alright. We would now like to take a moment and thank our mentor, Dr. Kaibalya Prasad Panda, for his constant support and guidance throughout this entire project. I would also like to thank our faculties and the electrical department at Pandit Deendayal Energy University for constantly providing us an amazing environment and a supportive space in their laboratories to carry out this experimental developing. I would lastly like to thank the Pandit Deendayal Energy University for providing us such an amazing support throughout our entire major project process. Thank you.